In this video, we are going to be talking about electrons. This is one of two videos about electrons, but by the end of this one, you'll be able to determine the number of valence electrons using your periodic table. So we first need to discuss how the periodic table is organized so we don't get confused on the numbers we're going to write on our periodic table for the valence electrons. So the periodic table is organized into periods and groups. Periods are rows, and so their numbers are on the side of the periodic table, and they tell you what row elements are in. So this is period 1, period 2, 3, 4, 5, 6, 7. Group numbers or groups are actually columns, and those numbers are found at the top, and they go 1 through 18. So 1, everything under the 1 is in group 1. Everything under 2 is in group 2. Everything under 3 is in group 3. And it goes all the way up to 18. And so they're vertical and periods are horizontal. What is a valence electron? So valence electrons are electrons in the outermost energy level of an atom. So here we have a picture of a carbon atom that has 2 energy levels or rings around the nucleus. The second one is the outermost energy level. It's the one that's closest to the outside, and it has 4 electrons. So carbon has 4 valence electrons. And I usually abbreviate valence electrons as VE. And these are important because they're the electrons that we use in bonding. So you'll see these valence electrons come up quite often throughout the rest of the year. Instead of giving you a picture of an atom every single time to find the number of valence electrons, you can actually use your periodic table. So we saw that our group numbers before were labeled 1 through 18, but when we talk about valence electrons, we don't include the middle section because they can have different number of valence electrons depending on which type of or which version of the element that you find of those. So we don't include those. But for valence electrons, 1 and 2 are still the same as your group numbers, and then 13 through 18 now become 3 through 8. So everything under those numbers tell you how many valence electrons they have. So everything under 1 has 1 valence electron, everything under 2 has 2 valence electron, everything under 3 has 3, 4, 4, and it goes all the way up to 8. There is one exception, and that is helium. Helium is found right here under 8, but it actually only has 2 valence electrons. And the reason it's under 8 with only 2 is because it has the same properties as everything else in that group. So that's the one that you're going to have to remember is slightly different and doesn't follow the pattern for valence electrons. Now, we can represent valence electrons using electron dot diagrams, and what they are is the element symbol and the valence electrons around it. So nitrogen is element number 7, and it's found right here. So nitrogen is under the number 5 for our valence electrons, which means it has 5 valence electrons. So once we write the symbol, we're going to place an electron on each side of the element symbol. So one on top, one on the right, one on the bottom, and one on the left. Once you have one on each side, then you can go back and start pairing them up. And so it needed one more to get 5, so we just added one on the top. If we were to do, let's say, let's do boron. Boron is number 3. It's right here where the blue X is. I'm going to write my symbol B, and it has 3 valence electrons. 1 on the top, 1 on the right, 1 on the left. Okay, don't pair them before you have 1 on each side. I want you to use your periodic table to complete the first example problem. You're going to find all of these elements, find the number of valence electrons, and then draw the dot diagrams like we just did for nitrogen and boron for all 8 of these. So pause, take a few minutes to do that, and then unpause to check your answers. If you're waiting for me to give the answer to you, do it. Please. Okay. Assuming that you did it yourself, these are the correct answers. Let's see if I can move my face so you can see argon. So Na has 1, Mg2, Al3, Si4. So you notice how all of these, we have 1 on each side. None of them are paired up yet. Phosphorus has 5, sulfur 6, chlorine 7, argon 8. So once we get past 4, then we can start pairing them up in the same order we put them in before. The next problem we are going to go over is 4 students wrote the electron dot notation for oxygen below. Which student is correct, and explain why the other ones are wrong. So if you get stuck with this question, I would do it yourself. Find oxygen, draw the dots to represent the valence electrons, and then compare your answer to the other answers you see. Okay. So pause, try it yourself. Okay, student 3 is the correct electron dot diagram for oxygen. Oxygen has 6 valence electrons. They put 1 on each side and then went back to pair it up. So this is how they did it. Oxygen, 1, 2, 3, 4, 5, 6. Okay. Student 1 is incorrect because they didn't put 1 on each side before they doubled up their valence electrons. So that one's wrong. Student 2 is wrong because they have 8 valence electrons. Now, the atomic number for oxygen is 8. They use the total electron number instead of valence electrons, which is wrong. You'll never have more than 8 valence electrons. And then 4 is wrong. Even though they have the right number of valence electrons, they just put them around oxygen. They didn't put them in any order, which we know is incorrect. If you got this question wrong, make sure you correct it so that way you have a correct reference to look back at when you need your notes. So valence electrons, the outermost electrons on an atom, those numbers can be found at the top of the periodic table, and they go 1 through 8. Not to be confused with your group numbers, which will go 1 through 18. So like once you get over here, your group numbers look like this, like 13, 14, 15, 16, 17, 18. Those are not valence electrons. Like I said, valence electrons will never go higher than 8. To represent valence electrons, we do electron dot diagrams, which is our symbol and our valence electrons. So nitrogen, found right here, had 5 valence electrons because it's under the 5, 1 on each side, and then you pair them up. Okay, so make sure your guided notes are complete, and then you can go ahead and move on to the next activity.